Let's get started with cloud-native Java applications on Kubernetes, an open-source hands-on workshop. Today, traffic management in Kubernetes with Istio. In our cloud-native starter project, we want to show how to control the routing for external requests to a specific version of our microservice called Web API. We want to do a canary deployment of that service. Canary deployment is a technique to reduce the risk of introducing a new microservice version to production. We can slowly roll out the change to a small subset of users before we roll it out and making it available for everyone. Therefore, we need to control the routing after the Ingress gateway. At a high level, Istio helps to reduce complexity of cloud-native deployments. Istio has a diverse feature set that let us successfully and efficiently run distributed microservice architecture and provides a uniform way to secure, connect, and monitor services. In our case, we need to understand from Istio using Envoy proxies to control inbound and outbound traffic from a Kubernetes pod. The Envoy proxy is injected as an additional container into a pod. Inside the control pane, we can configure these proxies. First, we define the Ingress gateway as our default gateway. Then we define a virtual service for that gateway. Here we map incoming requests like getMultiple to our Web API microservice. Because of the usage of Istio, we can add additional information for weight of use for the different versions of our Web API microservice. All these is relevant for the service we do define for the Web API microservice. As we know, a service in Kubernetes is responsible to route requests to the right pod containing the microservice. Usually in Kubernetes, without Istio, we would have a service for each pod. When we have two versions of a microservice, we must define the routing to each version of the microservice. But with Istio, we route to more versions of the microservice with one service using the destination rule. And this is realized with the destination rule, Envoy proxies, and the virtual service. In a screenshot, you can see the Web API routes to two pods. The percentage distribution we define in our virtual service before. Let us take a look at the running sample. Here we see the running frontend of our sample and Kiali. Kiali helps to define, validate, and observe our Istio service mesh. We're using the graph for the traffic animation. We frequently update our web app and observe the requests to the Web API microservices. 80% were routed to the Web API version 1 and 20% were routed to the Web API version 2, as we have defined. Do you want to know more? Get your hands dirty, have fun, and provide feedback. The links to the Cloud Native Starter project and the related part of the workshop is below in the description. Have fun and bye.